equals 6 here. Okay, now this is a video which is I'm recording for AHL 2.9. It gives you an overview of that. Okay, so these are the models: natural log models, natural logarithmic models, sinusoidal model, logistic model, and piecewise. This is what I'll be discussing in brief. Now the natural log model is based on a log graph. This is your ln graph basically. Your ln graph, so your natural log model is of the form y is equal to a plus b ln x. So your ln x graph is like this. Your b is your vertical stretch factor, so there will be some stretch which will be there that will affect the points on the curve, and a is your vertical translation. So what's going to happen in this case? So always when you have this model, your 1 comma a and in e comma a plus b will lie on it. So 1 comma a. So basically when your x is 1, your ln1 is 0, so y will become a. Basically that's what's showing. When x is equal to 1, so 1 comma a will always lie on this. When your x is e, your a plus b ln e is 1, so a plus b will lie on it. So basically these are the 2 points that will always lie on this. Okay, so if I go on the next page and see the sum based on this. Now this is a typical sum that will come in. The strength of an earthquake on a Richter scale R is the log model. R is equal to P ln A plus Q. The amplitude is 2 mm. The strength of the earthquake is 3. So the strength is R. Correct? So this is the strength. This is the amplitude. So they've given the strength is 2. This is 3. Okay. And also they've given you when the amplitude is 25. The strength is 4. So basically put in the value of A and R in this. Get the model, get the value of P and Q. Once you get the value of P and Q, you will get the model. And once you get the model, you can find any other value which is there, basically. Correct? So the strength of the earthquake for which the measurement of the seismograph is 100 mm. So again, your seismograph is measuring the amplitude. So mm is your amplitude. So you put your amplitude as 100 and you get the answer. The seismograph needs to measure earthquake of strength between 2 and 5. So between 2 and 5, the strengths are 2 and 5. So you find out the amplitude when the strength is 2, when it's 5, and the amplitude is between that. With unrounded values, it will be this. Okay, now in this case, a sinusoidal model is a sine function. So y is equal to a sine b x minus c plus d. A is the amplitude. You can find the amplitude by max minus min divided by 2. I don't know whether I've written that here or not. No, but you can remember that. Your amplitude is your max value minus min value divided by 2. B is equal to 2 pi divided by period. So B affects the period. C is the phase shift. Now this is a tricky thing to do, which I'll be explaining here. And D is max plus min divided by 2. D is your midpoint basically.
Yes.
This midline. Now your C is the phase shift. So your sine function, the basic sine function always starts from 0, 0. 0, 0 is your sine function. If this is translated pi by 4 units to the right, your C will become pi by 4. A minus sign is there, resident in the formula. So when it shifts to the right, you write x minus pi by 4. When it shifts to the left, you write it x plus pi by 2, because x minus pi by 2. So basically this is your phase shift. So when you're looking at a phase shift, you look at this point on the sine curve and you see how much has it shifted. This is what you have to do. This is what I said exactly. You find a max min. You have to check what the max, what the min is. You can pause the video and do the sum. It's just based on the concept that I just mentioned. You can just do this one sum, and any sinusoidal function will be of this sort basically.
Yes.
Now let's apply the sine to the different sine function, to this sum 29. On the same diagram, sketch y1, 2 sine x. You have to use your calculator and sketch it. But remember, do not sketch it outside the domain. If this domain is given 0 to 4 pi, sketch only for the domain. Another important thing is your calculator has to be in radian mode. Whenever pi by 3 and the domain is given in radian, just keep your eye and see that your calculator is in radian mode. It shows on the top part, radian. Use technology to sketch y3 is equal to y1 plus y2. Achha, so this you have to, obviously from the screen to paper you have to transfer it. You look at the max and min. Obviously your amplitude is 2 and this the amplitude is 1. Correct? So the red graph is your 2 sine x and your purple graph is this x minus pi by 3. Means it shifted pi by 3 to the right, as you can see.
Yes.
Huh? Now, use technology to graph y3 is equal to y1 plus y2 for the same domain. So this is what you shifted, you graph that. This is what your calculator looks like. Your y1 plus y2. Labeling the max and min. So you label the max, you find G sol max, G sol min, G sol max, G sol min. Also get the intersections if you're copying this on this. So plot the intersections also, max min, and then you join them. Okay. Suggest an expression for y3, this graph that you get, in the form a sine b x minus c. So a is your amplitude. Your amplitude you can get this max minus min divided by 2. So your max is 2.65, your min is minus 2.65, max minus min divided by 2 is 2.65.
Yes.
B is your period. B is equal to 2 pi divided by period. Now what is a period? Period is one cycle from one class to one class. Or if you have a max and min, you can subtract that and also do it. Or you from one max you find the other max and subtract. You'll get a period from one max to other max, or from one min to another min. Or if you're taking the x values from max to min, you take that and double it. You'll get the period. So b is equal to 2 pi divided by period. So that's 1. Now, so you got your a, you got your b. Now your c is the translation. You look at this value. You have to look at the sine graph. No? So you have to get this point. So that's your horizontal translation. So you get the translation. It's shifted so many units to the right. So therefore your answer, so that's your 0.3334. Huh? So your 2.65 sine, your b was 1, x minus 0.334. Okay, now a logistic model. Logistic model is generally used for population growth in anywhere in the world. You know, this is your start point. First there's an exponential increase. There's a point of inflection and then the population starts lowering and then it levels off. For any business also this happens. You know, first you'll have exponential growth. You'll have a point of inflection. More competitors will enter the market and then your business levels off. You know, this is thing in anywhere. Because, you know, any competitive market, this is going to have. You'll get a logistic model. But there's a leveling effect, basically. So there's an exponential growth, point of inflection. The growth rate decreases and it levels off. Okay. A logistic model is of the form y is equal to L 1 plus C e raised to minus x. You have to learn this form. It's there in your formula booklet as well. Where L is the eventual population size, also known as the carrying capacity. So y is equal to L is your horizontal asymptote. It's where things level off. Equilibrium population is reached, you can say. Correct? So that's this L. L upon 1 plus C is the initial population. It's very simple. You don't have to learn this. You just put your x as 0.
Yeah.
When you put your x as 0, L upon 1 plus C, that's your initial population. And K measures how quickly the population is growing. K measures how quickly the population is growing. So this is what you need to remember in logistic model. The values will be given, you have to just substitute and solve. There's nothing you have to remember. So like this. Rabbits are introduced in an island at a rate of 100 rabbits per year for 3 years. So you're putting in 100 rabbits for 3 years. State an assumption required and find the population rabbit at the end of 3 years. There is no death or breathing of the rabbit. The population will be 300 rabbits. Yes. This is a very stupid thing to ask, but anyway. After 3 years, now this is where the sum starts. I don't know why they did this. After 3 years, rabbits are no longer introduced and the population is thought to follow logistic model. So you start applying logistic model here, not here. With a carrying capacity of 1000 rabbits. That's your horizontal asymptote. 4 years after the rabbits were introduced, the population is 450. Using this model, estimate the population 5 years after the rabbits were introduced. So obviously your answer has to be less than 1000. One thing you know for sure. You won't exceed this.
Yes, sir.
So I start with my logistic model. N is equal to L upon 1 plus C e raised to minus kt. You know L is the carrying capacity, which is given to be 1000. Correct? Your N is 300. correct? Your n is 300, and what is the value of
300 is what, sir? The
300 is first introduced, no? 300 is year. The 300 when your time is 3. First introduced for the first 3 years, there's no. So 100 first year,
yeah, sir.
200 second year, 3 years. So starting point is what?
Oh, okay. Fine.
Your starting point is 3 years. Your starting point is 3 years you have taken. Then therefore they have done this. Oh, I thought. So when your n is 300 at end of 3 years basically.
Okay.
Correct? So end of 3 years. So and so you put that, you'll get, you make c e raised to minus 3k the subject of formula. You can basically get your c. When your t is equal to 4, that's another variable. When t is equal to 4 years after, so 3 years after the rabbits were introduced, the population was 300. 4 years after they introduced, it's 450. So 450 in 4 years. You put in the same model, 450 in 4 years. That will again make c the subject. You cross multiply and all that, make c the subject. Equate them. You can use n solve and get the value of k. Put this k back. Put this k back. Correct? And now you want a value of c. If you put your k over here in any one of this equation, you'll get the value of c. And that's your model. Are you following that?
Yeah.
So this model we have to know L, C and K. 3 things have to be known. So L they gave you. We calculated C and E from the other data. And then whichever year they ask you to find a population, put that and get the model. That's it.
Okay.
The next thing which is there then is the piecewise continuous function. A function is said to be continuous if you can draw the graph of that function without lifting the pen off the paper. I mean, that's an informal definition.
Yeah.
Now, piecewise function is, a piecewise function consists of different pieces. Each of the pieces defined for the domain. So when your x is less than or equal to 2, your function is x plus 1. When your x is greater than 2, your function is ax plus 2. Find a if fx is continuous piecewise function. Sketch a graph of the function. So they'll give you some like this. They'll give you fx, they'll give you some unknown, and they say it's a continuous piecewise function. Find a. So what you do is you put 2 in this expression, and you put 2 in this also. Even though it's not equal to 2, you still put it, because you don't want to break. So 2 plus 1 is equal to 2a into 2 plus 2, basically equate them. They should level up. Correct? They should level up, when this gap shouldn't be there. There should not be any gap. When the first one ends, the second should begin from there only. So when your a is equal to half, the second one will begin from here itself. When they ask you to sketch the graph, in your calculator, this is the notation you can use. y1 is equal to x plus 1, comma, open a box bracket. The box bracket is there. If you press shift and plus, you'll get a box bracket. Shift and plus and shift and minus gives you a box bracket. So you can plot like this. You can do this and you'll get your piecewise function on your calculator. You just copy that. This is what about your piecewise function. This is an important tough sum. It's about the exponential growth. So the initial population of worms in garden is n0. In the first half of the year, the population grows exponentially. So here you have to use what we call the exponential model. So this is the exponential model. Correct? N is equal to n0 e raised to kt. Fine. In the first half of the year, the population grows exponentially, so that the time taken for the population to double is this. So you put your time taken and you put your population as 2n0. You solve for alpha, you solve for k basically. So this is the model that you have. So this is the model that you have. N is equal to n0 e raised to this. Now for half a year, the population keeps on increasing. So at end of half a year, you put your time as half a year, 0.5. And the population, this is the population at end of half a year. Now, so that becomes the new, this initial population. And after that, the population decreases. So you put a minus sign, beta t. And then you solve this.